Hello and welcome. You know that box sitting on your desk. Today, we're going to take a really simple and calm tour inside to see how your computer really works, piece by piece.
You know, if you've ever felt that a computer is some kind of magic or just way too complex to understand, you are not alone. But the truth is, the basic ideas behind it all are surprisingly straightforward. So let's begin our tour. To start, there's really one core concept to grasp. Every single computer, from the one in your phone to a giant server, is made of two different kinds of things. On one hand, you have the hardware. These are all the physical parts you can actually see and touch. You know, the screen, the keyboard, all the little chips inside. Think of it like a person's body. And on the other hand, you have the software. These are the instructions, the programs that tell all that hardware what to do. It's kind of like the thoughts and ideas that make the body work. One can't really do much without the other. So let's see how these two work together. It's really just a simple three-step process. First, you provide an input, say a click from your mouse. The computer then processes that command, and finally, it gives you an output, like a program opening up on your screen. This simple little cycle, input, process, output, is the foundation for everything your computer does. So let's start with the physical stuff, the hardware. It's time to metaphorically open up the computer case and meet the key players that make up the team inside. Okay, this might look a little complex, but just think of it as a team photo. Each of these components has a very specific job, and they all have to work together perfectly. We're going to introduce the most important members of this team one by one. First up is the motherboard. While this image looks complicated with all those slots and ports, its job is actually pretty simple. It's the backbone of the entire computer. Everything else plugs right into it, and that's what allows all the different parts to talk to each other. It doesn't do the thinking itself, but without it, you just have a box of loose parts. Now, sitting right on that motherboard is the most important chip of all, the CPU, or Central Processing Unit. If the motherboard is the backbone, the CPU is absolutely the brain. This is where the actual thinking happens. Every single command, every calculation, every instruction flows through this tiny but incredibly powerful chip. Of course, for a brain to think, it needs a place to hold information. In a computer, this is handled by memory and storage. And there are two main types. One for short-term work, and one for long-term safekeeping. On the left, we have RAM, or Random Access Memory. Think of this as the computer's desk, its temporary workspace. It's super fast, which is why the computer puts whatever it's actively working on right there for quick access. But just like a real desk, it gets cleared off when the power is turned off. On the right, we have the hard drive. This is the computer's permanent filing cabinet. It's a bit slower, but it's where you store everything for the long haul, keeping it safe and sound even when the computer is off. And here's what they actually look like. On the left, you can see the RAM sticks. That's the temporary workspace. And on the right is a hard drive, the permanent filing cabinet. Two different parts with two very different but equally important jobs. So here's a quick question, just to connect these ideas. When you've been typing up a document, but you haven't hit save yet, where is all that work being stored? Is it in the temporary workspace or the permanent filing cabinet? That's right, it's living in the computer's temporary workspace, in the RAM. And that's exactly why, if the power suddenly goes out, your unsaved work is just gone. The act of hitting save is you telling the computer, okay, take this from my temporary desk and go file it away permanently in the hard drive. So, we have our team of hardware components. We've got the backbone, the brain, and the memory. But how do they all work together? I mean, who's in charge? Well, that brings us to our final key player. We have all this powerful hardware just sitting there, ready to go. The CPU is ready to think, the RAM is ready to hold information, but what tells them what to do and when to do it? There has to be some kind of manager coordinating the whole operation. And that manager is the operating system, or OS for short. This is the masterpiece of software that brings all the hardware to life. Think of it as the conductor of an orchestra, or the manager of the team. It tells the CPU what to process, it manages what goes in and out of memory, and it allows all your other programs to run. And you're definitely familiar with an OS, even if you don't think about it. Microsoft Windows is one of the most famous examples, but others include Apple's macOS and Linux. When you turn on your computer, this is the first piece of software that boots up to get everything else ready to go. Okay, so we've met the team, all the hardware parts, and the software manager. Now let's put it all together and see how they work on a simple, everyday task. It all starts with your input. Let's say you click on a program icon. Instantly, the operating system sees that command. It acts as the coordinator, telling the CPU, the brain, okay, time to get to work. The CPU then pulls the program information it needs from the hard drive, puts it into RAM, that temporary workspace, and starts processing it. Finally, the result of all that work is sent as output to your screen, and the program opens. And all of this happens in a tiny fraction of a second. And that right there, that's really the main idea to take away from this. A computer might seem like one single object, but it's really a highly effective team. A team of specialized hardware parts, all being directed by one very smart software manager, the operating system. So next time you click your mouse or type a sentence, you can actually picture that entire team springing into action. It's not magic at all, it's just really, really good teamwork. And now you know exactly who's on the team.